Okay, this is a lesson on intersecting a line and a quadratic function using the graphing calculator. Homework tonight will be packet pages 45 or 44 and 45. What I'd like you to do is to please turn to page 40, type the equations into your calculator, and fill in the table, and then make a graph of both on the same grid. Alright, so I'm going to go to y equals. Again, please write down your homework. And that's going to be x squared plus 5x minus 4 in y1. And then in y2 it's going to be 3x minus 5. Now the first thing I'm going to do is I'm going to take a look at a table here. Again, I see I need it from -3 to 3. I can't put this up. So let's make this like alright, so here we go. I'm just going to recopy this down here. So I've got -3 is -10, -10, -8, -4 for 0, 2. Then this one is -20, -17. Oops, wait. It's a 14. Oh crap, I did this from the wrong one. -3 is -14, and then -2 is -11, and this is -8, this is -5, -2, and then at 2 it's 10, 1, and then this is 24. Alright, so let's look at the graph. We can see, whoop, this is a weird window, zoom 6. So we can see, here's the parabola, and here comes the line. And you can see it kind of skims along the parabola right here, and that occurs at -1. So if you were to graph this, and I'm not going to plot the points, although you can, we know the solution is going to be x equals -1. Alright. If you turn the page, these are the answers to last night's homework. You can look at this on YouTube if you want later. Alright, so here's what we're going to do. We're going to use the graphing calculator to find the solutions to each of the following systems. So everybody go to y equals, and we're going to type in the equations for the first one. So we've got, and then plus 3x minus 5. And this one is going to be x plus 3. Alright, now let's take a quick look at the graph. So when you look at this graph, how many solutions do you see? Right, I see 1, 2. So what I'm going to do is I'm not going to draw a really accurate graph, but I'm just going to kind of draw that it looks like this. And I have two choices here. I can go look at the table and see if I can see where the x values are. And this is like a hunt peck thing. Okay, I found one of them. It's at 2. And if they're integers, I could find the other one. Oh, there it is, -4. So I've got the point -4, -1 is a solution, and then 2, 5 is a solution. And for number 1, that works out pretty well using just the graph and the table. Now let's take a look at number 2. So go ahead and change it. So this is going to be -4 x plus 6. And this one is, instead of x plus 2, I'm going to change it to x plus 3. Or I'm sorry, instead of x plus 3, I'm going to change it to x plus 2. Let's take a look at the graph. So there's my parabola. And there's the line. So again, I have a situation where it's a parabola and then the line cuts through. So let's see if we can, so I think it's like at 1 and maybe 4. Let's take a look at the table. Oh, look, 1 and comma 3. And so what was the other one we thought? 4. I hate this calculator. Oh, yep, there it is. 4, 6. So 4. Now, these were nice integer answers, and that works great. But what if they're not integers? I want to show you how to use something called the intersect feature. Oh, I can't spell. Intersect. And the way we get to our intersect feature is we're going to go second trace. Now, if you remember, that's where minimum and maximum were. So if we go to second trace, now we want to pick number 5, because number 5 is intersect. You will like this. This is easier than min and max. So pick number 5. Now, it says first curve. Now, the good thing is we only have 2 things graphed, so we don't have to like pick the curves. It's on one of the graphs. It's on the parabola. See, it says y1. We're going to press enter. And then it says second curve. And what does it say up here? y2. As long as you don't have more than 2 equations entered, it's going to pick the first one and the second one. So I'll press enter. Here's where it makes a difference. It says guess, and there's our little blinky man. See him? We need to move the guess to where they overlap. So see how I moved it right here? So I move the arrow, the cursor to the guess and press enter. And there it is, 1, 3. Let's do it again and find 4, 6. So let's go second, trace. I'm going to pick number 5. Enter for the first curve. Enter for the second curve. Now, if I just press enter again, look where the cursor is. It's right on that previous answer. So I have to move it. Come on, buddy. Over to this other one that I wanted to find. That looks good. See how now it's overlapping the other? The blinker is overlapping the other intersection point. So then I'll press enter, and it gives me the other one, 4, 6. Now, when you're dealing with word problems that have decimals, this is going to be the method you want to use because you might have like 1.5 seconds, not exactly 1. Let's go ahead and turn to page 41. All right, so here we go. We've got Tristan throws a football out of a bus window to Matt, who's standing in the parking lot. The height of the football, so this is going to be y1. Let's go to y equals and clear them out. Clear, clear. All right, let's type in -2 x squared plus 6x plus 8. All right, so we can kind of guess if we throw the football out the bus window, the football's going to go up and then the football's going to come down. Matt sees the throw is high and jumps to catch the ball in the air. Matt's height is modeled by the function 2x plus 2. So that's going to go in y2. Oh, that doesn't work. 2x plus 2. All right, so let's go ahead and hit graph and see what it looks like. And there the ball went up and the ball came down. And there's his buddy Matt. Now I want to remind you of something. Even though we see it cross 1, 2 times, we want to remember this is a word problem. We don't really pay attention to any of this negative area. So even though we see the ball go up and then come down and we have a line here, now we have to be careful about our axis. So I'm going to just draw this in really quick. Okay, because I want to be clear that I don't care about this. This is all garbage. All I care about is positive time and a positive height. So I'm looking for this solution. The way I'm going to do that is just with the second trace intersect. So everyone go to second trace, pick number 5. Enter for first curve, enter for second curve. And then we're going to move it. Come on, buddy. dun, 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 dun. Oh yeah, it looks good. So I'm going to put the blinking cursor over where I think he catches the ball. And I'm going to press enter. Oh, and it is perfect. 3-8. So, does Matt catch the ball before it hits the ground? Yes. He catches... You know, I'm going to type this. This is terrible. Know your handwriting. Let me take it. Yes. He catches it after 3 seconds at 8 feet in the air. I found the intersection of this graph, and I'll draw a little arrow to that graph in a second, using the intersection function on my calculator. Ta-da! Perfect answer. All right, so let's do one more together. This graph. All right, Gene is the kicker for the Sherwood football team. He kicks a field goal from the 20-yard line. The height of the ball is modeled by the function. So even though there's t's here, guys, we're going to put them in as x's. So hit clear. Negative 16x squared plus 25x plus 7. And then we're going to go with the height of the field goal. The posts don't move, so 10 is it. Like, it's always 10 feet high. Ooh. All right. I don't see anything. Well, I kind of do. Here's the line. I can see it goes through. So let's go and hit the Y max. Let's change my Y max just a little bit. Window, because if it's 10 feet high, I probably might want to make that like 15. All right, here we go. So it goes up, but he kicks the ball, and the question is, he must be above the goalposts. Oh, write an inequality. So the inequality needs to be the height of the ball, which is the function, must be greater than 10. On what intervals is the ball above 10 feet? So I'm going to make my little sketchy poo. Ooh, oh, that's terrible. There we go. And it goes like this. So I need to find this point and this point, and I'm going to use my calculator. Second trace, number 5, first curve, second curve, and my blinker is kind of already on that first one. Ooh, look at that. That's really small. So here we go, 0.13. Now we're talking. So 0.1310. Let's find the other one. Second trace, 5, first curve, second curve, arrow, 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 arrow. Come on, Blinky. That looks good. See how it's like right there? All right, we've got 1.43 comma 10. So on what intervals is the ball above 10 feet? Typing time. Between 3 seconds and 1.43 seconds, the ball is above 10 feet. And again, you can just steal that answer you used before. I found these times with the intersection feature of my calculator. L-A-T-O-R, period. All right, so with your group, I want you to work on the next 2 pages. I'll put the answers up in a minute. So I want you to work on page 42 and 43. And homework tonight is 44 and 45. So hit it, 42 and 43. Now, I'll be honest with you, the person who did this used the quadratic formula. I would have just used my calculator to type them in and find those intervals. You might need to change the windows. You'll be okay. And then here's page 43. Again, this person used the quadratic formula. I would have just used the graph, and you will probably need to adjust the window. Homework tonight is 44 and 45.